Alright, so we are going to be adding and subtracting rational expressions today. So the first one in our examples is going to be a monomial on the bottom, meaning there are no plus or minus signs. So what we're going to do is we're going to figure out what we can make the bottoms so that they match. So what I like to do is I like to list all my terms out. So I have an x squared, a y, a 3, an x cubed, and a y. Okay, so I'm just going to list something that I have. So in this case I have a 3. If this was like a 6 and a 9, I would factor them both or think about what I could make them both into. I have an x squared and an x cubed. So unlike factoring, it's not going to be the least, the smallest exponent, it's going to be the biggest because we can make x squared into x cubed by multiplying by x. So we need to make it 3x cubed, and then they both have a y. So the x cubed again is going to take away the 2 of the x's, the y is going to go away, the 3 already went away. Okay, so this is our LCD. So that's going to be the first thing that we list. So we're going to list off to the side, the LCD is 3x cubed y. Then we have to figure out what we need to make both of them look like that. Okay, so this one, we need a 3. And we need our x squared to turn into x cubed, so we need to multiply by a 3 and an x. If we do it to the bottom, we have to do it to the top. So we're going to multiply 3x to the top and the bottom. This side, we have a 3 already, so that's good. We have an x cubed, and we have a y, so this is already in our least common denominator. Okay, so now what we have to do is multiply these two things together. So 2 times 3 is 6. Our x is just going to follow, so we're left with 6x. 3 times x squared y is 3. X times x squared y is x cubed y. We're just going to copy down the second one because we didn't have to do anything. And now our denominators match, so we're going to add straight across for our top. So we have 6x plus 5. Over, our denominator does not change, so it's 3x cubed y. We don't have any common terms up here, so that would be the end answer. Okay. For example 2, we have some binomials. So we have 5k over k squared minus 4 minus 2 over k squared plus k minus 2. So we need to first factor the denominator. So we would have 5k. Factors of negative 4 that add to 0 would be positive 2 and negative 2. So k minus 2, k plus 2. We'd have our minus sign. Factors of negative 2 that add to 1 would be 2 and 1. To decide which one gets the negative, you look at the sign. We need a positive number, so the bigger number gets the positive. Okay, and now we need to find our LCD. So each one has a k plus 2, so that has to be in our LCD. So we have k plus 2 needs to be in there. We have a k minus 2, so that needs to be in there. And last, if you look, we have a k minus 1, so that needs to be in there. Okay, so this is our LCD. Now we're going to look at each fraction and see what we're missing. I'm trying to get it all in one window. So we have over here a k plus 2, a k minus 2. So we're missing our k minus 1. So we need to multiply by k minus 1. Okay. Over here we have a k plus 2, a k minus 1. So we're missing a k minus 2. What we do to the bottom, we have to do to the top. Okay. And then we are going to just distribute or FOIL. And then we're going to combine our like terms. So for the first one, we're going to have 5k times k to get 5k squared, 5k times negative 1 to get negative 5k. We're subtracting this whole thing. We're going to distribute in our 2, so we have 2 times k is 2k, 2 times negative 2 is negative 4. And then we have our denominator of k minus 1, k plus 2, k minus 2. Doesn't matter the order that it was originally in, we're just going to make it match. And then we need to subtract. So the big thing about the subtraction is it needs to go and you need to subtract both terms. So the way I like to do it is I like to change it to a plus and then switch both the signs after. So plus and then switch my signs, and now I can just combine like terms. So I don't have anything with the 5k squared. Negative 5k and negative 2k make negative 7k, and then no like terms with a 4. I'm going to rewrite my denominator because it's still in fractional form. That is my final answer. If you wanted to check to see if this factors a 20 that add to 7, we factor out 20 all the way, and we get that there are no factors that add to negative 7, so it's not factorable. So usually that'll be the case, and this is our answer.